Hi friends, let us discuss about one very important aspect of calculus, differentiation. Okay, before differentiation, let us briefly discuss about slope. We know slope of a straight line, right? What is slope of a straight line? If there is a straight line like this, if there are 2 points, x1, y1 and x2, y2, these are the 2 points. What is the slope? Slope is y2 minus y1 by x2 minus x1, right? There are 2 points. Basically, this is the slope of this line. Whether you take these 2 points or some other points, or in fact, even if you take a single point, the slope of the line is always the same. This line, whatever slope is, the slope is let's say 1, then whichever 2 points you take, they will always give the slope as 1. y2 minus y1 by x2 minus x1 will always be 1. So, what is this y2 minus y1? What is this x2 minus x1? If you briefly see, let's say if this point is x1, y1, right, and this point is x2, y2. What does that mean? What is y2 minus y1? y2 minus y1 is this part, right? The length of this part is y. If we are talking about a coordinate axis like this part is y2, and this one is y1. So y2 minus y1 is actually length of this one. What is x2 minus x1? This one is x2, and this one is x1. So x2 minus x1 is length of this one. Right. And if we assume this is theta, then basically tan theta is equal to this thing, y2 minus y1 by x2 minus x1. So what is our slope? Slope is basically this one, which is nothing but our tan theta, and we define it like this. Now let us try to extend this concept to some curve. If, let's say there's a curve like this. Right, there's a curve like this. Now how do we define the slope of a curve? Straight line, it's very easy, right? Whichever point you take, whichever 2 points you take, you'll still get the same slope. But for a curve, it becomes a little tricky because if you take 1 point here and another point here, you will get one line, right? But on the other hand, if you take 1 point here and another point here, you will get a different line connecting them, right? There are multiple ways as long as when your 2 points are changing, or if you are keeping 1 point same, another point you are moving, then the slope is actually changing. How do you define slope of curve? This is very tricky, right? Slope of curve, and this curve, if you see here, the slope is lesser than the slope here. For example, if I am trying to sit here, then obviously I can sit comfortably. But if I am probably trying to sit here, I might fall down, right? I might fall down like this. Right. So slope of a curve is not constant, whereas slope of a straight line is actually constant. Whether you can sit here, you sit here, everywhere it is the same straight line. Basically, if you throw an arrow, it will go in this way. But slope of a curve, how exactly do we define the curve? Right. How exactly do we define the slope of a curve? If this point is x1, y1, and this point is x2, y2, can we still call y2 minus y1 by x2 minus x1? Right. This is a fantastic question. Then mathematicians they agreed that we'll still go with this one, but what we do, these 2 points, let's say this point is P, this point is Q, this Q should come very close to P. Right. Basically, what they are saying that these are called secant lines connecting P and Q. Let's say these are called secant lines. Right. Now, this when Q comes very close to P, this secant line, whatever this is connecting two different points, that will when Q coincides with B, right, the secant line will become a tangent line. Right. This is called a tangent. Otherwise, it's a secant. So, for example, if you look at this picture, right, this point is P, this point is Q. Now, this is a secant line, this black one. Right. And when this Q point comes closer to here, as when it comes closer and closer. So at this point, this is this line, then this is this line, then this line, likewise. If this Q point comes closer and closer, then that becomes this pink line, which is called tangent. Right. So the mathematicians agreed that slope of a curve is actually slope of this tangent. Okay, so now what is the slope of this line? So slope of this secant line, it's actually again y2 minus y1 by x2 minus x1. Right, now let us use a slightly different notation. Instead of calling x1 y1, x2 y2, we'll say x1 as x naught and y1 as f of x naught. Okay, value of this function, because this is a curve, value of this function is y1. That is this point. And instead of calling this one as x2, we'll say it is the distance is h. We'll say this point is x naught plus h. Instead of x2, let's call it x naught plus h. Okay, obviously what is y2? Y2 is what is this one? What is this height? Y2 will be obviously f of x naught plus h. That is y2. Right. Y2 will be f of x naught plus h. This is x naught plus h, and y2 is f of x naught plus h. Right. Now, what is our slope? y2 minus y1 by x2 minus x1. Right. Slope of the secant. What do we do this? Then f of x naught plus h. What is y2? Y2 is f of x naught plus h minus what is y1? F of x naught by what is x2? X2 is x naught plus h minus x1 is x naught. Right. So this x naught will get cancelled. So this is the slope of this secant line. Okay. The slope of the secant line is this. When this is h and this point is x naught plus h and f of x naught plus h, and this point is x naught and f of x naught. This is the slope of this black line. Now, how do you find the slope of the curve at this point? Slope of the curve at this point is not the slope of this black line. It is the slope of this pink line. What do we do? Then we'll say, we'll put a limit to this, and we'll say this h should get smaller and smaller and h should approach 0. What do you mean by h approaching 0? When h is smaller and smaller, obviously then you are forcing this point q to come closer and closer to this point p. That is what we are doing. When h is somewhere like this, then point q will be somewhere here. When h is somewhere like here, when h is smaller, then point q will be here. This is point q. When it is here, this is this. This is here, this is here. Right. When h is going smaller, then obviously q also is coming closer to p. Right. When h is tending to 0, what is the slope of this straight line? The slope of this tangent is actually f of x naught plus h minus f of x naught by again h. So this is called a derivative. Okay, derivative is another name for slope, and this is how we calculate slope of a curve. Please note, slope of a curve is slope of a tangent at that point, slope of a curve at x naught at a particular point. Slope of a curve is always at a particular point. What exactly, if you draw a tangent, what exactly is the slope of the tangent? Right, that is the slope of this curve. That is how we started with slope of a straight line, and then we tried to use the same definition. Then we realized for a curve, for a point at a point you want to say, then its q can be, if q is arbitrary, then depending on q, the secant line is changing. Then we agreed that the q has to be very close to p, so as to define what is the slope at p. Okay. So now what is the formal definition? The slope of a curve y equal to f of x at point p x naught f of x naught is this limit f of x naught plus h minus f of x naught by h, provided this limit exists. Right. So basically what you are saying, this h should get closer and closer to this x naught. This h should get smaller and smaller, so that this f of x naught plus h, this q, and this point will get closer, and then this one is actually the slope, that is again y2 minus y1 by x2 minus x1 is actually slope, which is also called the slope of the tangent. Okay, so that is this formal definition. Right, guys. Now let us look at some examples. Let's say some curve like y equal to 1 by x. This is the curve. Right. Now you want to find the slope of this curve at some particular point x not equal to a. Okay, at a particular point, or at a particular point x not equal to 2 or minus 2. Okay, this is 2 and x naught is, this is minus 2 and this is 2. X not equal to 2. Right. Then what do we do? F of x naught plus h. This is y2 minus f of x naught. This is y1 by x2 minus x1, which is actually h. And this limit h should tend to 0. Right. That is this one. That is our formula. Formula for slope. Now what is x naught plus h? If we take one random point a. Right. F of x is what? F of x is 1 by x. And what is f of x naught plus h or f of a plus h? F of a plus h will be 1 by a plus h. And minus what is f of a? What is f of a? F of a is 1 by a. Right. By h. Right. What does that mean? You can do this a minus of a plus h by a into a minus a plus h into h. Right. This a and this a will get cancelled and we'll be left with one h in the numerator. We'll be left with one minus h in the numerator and a h in the denominator. This and this will also get cancelled. We are left with minus 1 by a times a plus h. Right. Now this limit we know. Because when h tends to 0, we directly know this is minus 1 by a square. Right. This is 0. This limit we can directly calculate. Now what does that mean? At a point a, the slope is minus 1 by a square. What does that mean? At point 2, the slope would be minus 1 by 2 square. That is nothing but minus 1 by 4. Similarly, at point minus 2, it is nothing but minus 1 by minus 2 whole square, which is also minus 1 by 4. Right. So, this line, the slope is minus 1 by 4. You can see clearly this pink line and this pink line are actually parallel. Because the slopes are same for both of this is minus 1 by 4 here, minus 1 by 4 here. So, these two lines are parallel. Basically, for this graph, at minus 2, the tangents are parallel to each other. Right, guys? Let us look at some other example. Okay. So, now we discussed about slope or differentiation. At the same time, when we talk about slope, there is another interpretation to the slope. What exactly is this? So, another interpretation is this y is changing with respect to x. So let's say if slope is 2, what does that mean? If x is changed by 1 unit, y will change by 2 units. If x is changed by 10 units, y will change by 20 units. Right. So what does that mean? This is rate of change of y with respect to x. That is slope. If x you are changing by 100 units, y may automatically change by 200 units. That is the slope. Right. So far we have discussed different interpretations of slope. Okay, let us summarize once again. These are all the same. One is the slope of this graph, y equal to f of x at x equal to x naught. Right. Let's take a small h. This point is q, this point is p. Then y2 minus y1 by x2 minus x1. That is the slope. The slope of the tangent to the curve y equal to f of x at x equal to x naught. Right. So this is the curve. This is the point x naught and f of x naught. Right. So what does that mean? The slope of the graph at this point is this. This is also same as the slope of the tangent that is drawn at this point. This is also same as the rate of change of f of x. That is rate of change of y with respect to this x at x naught. That means x naught is changed by 2 units. This f of x naught will be changed by, if the slope is m, 2m, m times 2, right? Then this is also called as derivative at a point which is this x naught, right? All four actually mean the same. Slope, the slope of a tangent, slope of graph, slope of tangent, rate of change of f of x with respect to x at this particular point, and the derivative at this particular point. All four actually mean the same thing. Right. Now let us look at some graphs and try to calculate some slopes. Okay, so let us take this graph. This graph is y equal to 4 minus x square. We know 4 minus x square, it's an inverted parabola, right? X square will look like this. We discussed it. minus x square is inversion of this. Alright, minus x square is inversion of this, and minus x square plus 4. So this graph is shifted 4 units upwards. This point is 4. Okay, so that is this graph firstly. Okay, now we want to find what is the tangent at this point, minus 1, 3. Minus 1, 3 is this point. At this point, what exactly is the tangent? What exactly is the slope of this graph? Very easy, right? What is the slope? The formula for the slope is f of x naught plus h by f of minus f of x naught by h. What is x naught here? X naught is minus 1, right? F of minus 1 plus h. What is f of x? F of x is 4 minus x square. Right, f of x is 4 minus x square. So f of minus 1 plus h, that is 4 minus 1 plus h whole square. Instead of x, we will put minus 1 plus h. Right, minus f of x naught. Minus, that is f of minus 1. What is f of minus 1? 4 minus 1 square. That is f of minus 1. This part is f of minus 1. This part is f of minus 1 plus h. F of minus 1 plus h minus f of minus 1 by h. That is the slope at minus 1, which is our x naught. Now if you try to simplify this, what will happen? This becomes 4. This 4 and this 4 will get cancelled, obviously. Right. And this minus of minus 1 will become plus 1. And this one minus of a plus b whole square, which is minus 1 square 1. Minus 2h into minus 1, minus 2h plus h square, right? Now this and this will also get cancelled. We'll be left with h square minus 2h, which is nothing but h into, we'll be left with minus of 2h. We'll be left with minus of minus 2h plus h square, which is nothing but 2h minus h square, which is nothing but h into 2 minus h by h. This h we can cancel. So what is left? When h tends to 0, the slope is actually equal to 2. So basically at this point, the slope is 2. Slope is 2. And this line is passing through minus 1, comma 3. So what is the equation of the straight line? Y equals y1 plus m into x minus x1. Right. We know y1 is 3 and x1 is minus 1. Right. So x minus 1. M, what is m? M, the slope is 2. So 2 into x minus y1. This is y equal to y1. y1 is again 3. So 3 plus 2 times x plus 1. This is our equation, right? 3 plus 2x plus 2, which is nothing but 2x plus 5. That is the slope of this line, right? 2x plus 5. This line. Okay. Very easy. What we have done, we have taken a simple point and then we calculated the slope of the curve. Slope of the curve is given by this at a particular point. Right, and we calculated the slope and we know the slope of a straight line as well as a point through which it is going. So we calculate the equation of the tangent. Let's take one more example. X minus 1 whole square plus 1. This is again a parabola, right? X square is this. X square 1 is this. One unit shifted. Sorry, x minus 1 whole square is this. 1 unit shifted towards right. And plus 1 is this one shifted 1 unit upwards. That is this one. So this is this one. This is our origin. 0, 0. Right. 1 unit shifted right. 1 unit shifted up. Okay. Now we want the slope at this point 1, 1. Okay. So x naught is 1. So f of 1 plus h minus f of 1. 1 plus h. If we have to substitute 1 plus h here. 1 plus h minus 1 whole square plus 1 minus again 1 plus h. Sorry, this is f of 1. F of 1 is 1 minus 1 whole square plus 1. Right. 1 minus 1 whole square plus 1. This is anyway 0. This and this will get cancelled. Right. And this and this also will get cancelled. We will be left with h square by h, which is nothing but our h. And limit h tends to 0. Obviously, this is 0. What does that mean? The slope of a tangent at this point is actually equal to 0. Right. Now, the slope is 0. This is a straight line parallel to x-axis, and it is going through this point 1, 1. What does that mean? That means the straight line equation is y equal to 1. That is this straight line. Right. Slope of the tangent at this point. Similarly, let us take one more example. This 2 root x slope at this point 1 comma 2. Right, 2 root x, we know how does it look. Root x will look like this. Right, 1 1, this point is 1 1, this point is 1 1. Right, and 2 root x is this point multiplied 2 times everywhere. Right, instead of this 1, it becomes 2. Right, that is this point 1 2. Okay, now at this point itself 1 comma 2, we want to find what is the equation of the tangent. What is the equation of tangent? First we have to find the slope of the tangent. What is the slope of the tangent? Slope at this point 1 comma 2. Slope at this point means x naught is 1, right? F of 1 plus h. What is 1 plus h? 2 root 1 plus h. Right, this is f of 1 plus h minus f of 1. F of 1 is minus 2 root 1 by h. Right, 2 root 1 plus h minus 2 by h. We are rationalizing this. So instead of this minus, we'll multiply with this plus. So what will this become? What will this become? A minus b into a plus b, which is nothing but 4 times 1 plus h minus 4 numerator by h times 2 root 1 plus h plus 2, which is this 2. We can attach it here. It becomes 2h times under root 1 plus h plus 1. This 4 and this 4 will get cancelled. This h and this 4 and this 4 will get cancelled. Here there will be 4h left. 4h by 2h is actually 2. And this part will be left. Right. When h tends to 0, this becomes 1. Right. Under root 1 plus 1 is... when h tends to 0, this is under root 1 plus 1, which is 2. 2 by 2 is equal to 1. So slope is 1. Slope is 1. And one point we know is 1 comma 2. So y equals to y1, which is 2 plus slope 1 into y equal to y1 plus m into x minus x1. What is x minus x1? X minus x1 is 1. So the equation of this line is y equal to x plus 1. That is this line at this point for this curve. Okay. Similarly, let us look at one more example. Another simple example. We want to find the slope of this tangent of this curve y equal to 1 by x square at this point minus 1 comma 1. Okay. Firstly, this is an even function, right? It is symmetric with respect to y-axis, right? At minus 1, whatever the value, at plus 1 also you will get the same value, right? Now again, what is our slope? Slope of the curve at this point, f of x naught plus h minus f of x naught. What is our x naught? X naught is minus 1. So minus 1 by x square. In place of x, we will put minus 1 plus h. Minus 1 plus h whole square minus f of minus 1, which is nothing but 1 by minus 1 square. Right, this becomes 1 minus 1 plus h whole square by 1 times minus 1 plus h whole square. Right. This simplifies 1 minus 1 square plus h square minus 2h. Right, this becomes minus h square plus 2h. Right, minus h square plus 2h, which is nothing but h into 2 minus h by whatever this part. Okay, this h and this h will get cancelled. So in denominator will be left with minus 1 plus h whole square. Right, and if we substitute h, we will be left with 2. 2 by 1 square and minus 1 square, which is actually equal to 2. The slope is 2 and the point is minus 1, 1. So we can write y equal to y1 plus m into x minus x1. Slope is what? Slope is 2. So this is m into x minus x1. x1 is minus 1. Right. That is nothing but we get y equal to 2x plus 3. Y equal to y1 plus m into x minus x1. Right. This is how we are calculating equation of tangent at a particular point for the curve. Right. Another simple example. For this curve, y equal to x cube. We know it looks something like this, and at this point, minus 2 comma minus 8. Again, first we have to find the slope. Slope is f of x naught plus h minus f of x naught by h. X naught is our minus 2. Minus 2 plus h. That means 1 by minus 2 plus h whole cube. sorry, this is x cube only, x minus 2 plus h whole cube minus f of x naught, that is minus 2 whole cube, right? This becomes a plus b whole cube and all. So we can still simplify this. If we simplify this, and we are getting a slope of 12, right? We are getting a slope of 12, that is this line. Now slope of 12, and the line is passing through minus 2 comma minus 8, y equal to y1 plus m into x minus x1. So the slope of the line, slope of the tangent, or the equation of the tangent is y equal to 12x plus 16, right? Slope is 12. Okay. Similarly, y equal to 1 by x cube. 1 by x cube, another example. We have to find the equation of tangent is minus 2 comma minus 1 by 8. How do you find the slope? F of x naught plus h minus f of x naught by h, limit h tends to 0. What is x naught plus h? It is minus 2 plus h. What is this? This is equal to 1 by minus 2 plus h whole cube minus 1 by minus 2 whole cube. Right. If we do some basic manipulation with a basic simplification, we are getting the slope as minus 3 by 16. And what is our equation? Y minus y1, or y equal to y1, which is minus 1 by 8, plus the slope m into x minus x1, which is minus 2. So we are getting this equation minus 3 by 16x minus half, that is this equation, right guys? So here is another interesting question. Find equation of all lines having slope minus 1 that are tangent to the curve y equal to 1 by x minus 1. How does this curve look? Y equal to 1 by x minus 1. 1 by x will look something like this, right? It has got both horizontal and vertical axis as asymptotes. Now 1 by x minus 1 is the same curve shifted 1 unit towards right. It looks something like this, right? For example, it will look something like this. This curve, this green curve shifted 1 unit towards the right. Now what we have to find, here we are not given a point, right? Here we are not given a point, rather we have to find the point. We have to find the lines where slope is equal to minus 1. We don't know what is the point. So let us try to find out. Right. Let us assume that point is actually equal to x only. 1 by x plus h minus 1, that is f of x plus, this is f of x naught plus h minus f of x naught. Instead of x naught, we are directly putting as x. This is minus 1 by x minus 1 whole by h. Right. If we try to simplify, we are getting what? We are getting minus 1 by x minus 1 whole square. Right. This should be equal to, the slope is given. What is the slope? The slope should be equal to minus 1. Right. This part should be equal to, this one should be equal to minus 1. That means 1 by x minus 1 whole square should be equal to 1. Right. X minus 1 whole square is equal to 1. X square plus 1 minus 2x is equal to 1. So that means x square minus 2x equal to 0. That means x is 0 or x is 2. Right. X is 0 or x is 2. Now, these are the 2 points. Right. And when x equal to 0 or when x equal to 2, the slope is actually equal to minus 1. Right. Now x is 0. What is y? Y is again 1 by x minus 1. Right. 1 by x minus 1, 1 by 0 minus 1, which is equal to minus 1. The slope is minus 1 anyway. Y is minus 1. X is 0. So y equal to y1 plus m into x minus x1. M is anyway minus 1. So x1 is actually 0. So the equation of the tangent is minus of x plus 1. Similarly, when x equal to 2, what is y? Y is again 1 by 2 minus 1, which is equal to 1. X equal to 2, y equals to 1, and then slope is also we know. Basically, we know the slope, we know the one point through which this line is passing. So we can clearly make the equation of the line. This is coming out to be minus of x minus 3. So basically, these are the two lines which have slope minus 1. Basically, these two lines are parallel and these two are tangents to this curve. Right, guys? Now, one interesting problem. Does the graph of this function have a tangent at the origin? Okay, here is the function. Does it have a tangent at the origin? Right. Firstly, then we should be able to calculate slope at origin of this curve. If the slope we are able to calculate, obviously we can have a tangent. Right. Now first let's try to calculate f of x naught plus h minus f of x naught by h. Here x naught is actually 0 because it is about origin. Right, f of 0 plus h, that is f of h minus f of 0. F of 0 is 0 already given. So what is f of h? H square sine 1 by h. By h. This h we can cancel here. We will be left with h sine 1 by h. Right. And h sine 1 by h, we know this limit is actually equal to 0. What does that mean? The slope is 0. That means this graph has a tangent. We are able to calculate the slope. Right, guys? Earlier we discussed this h sine 1 by h limit why it is 0 because we use the sandwich theorem. Right? We use sandwich theorem. H sine 1 by h will always be lesser than h. Right? We use the sandwich theorem that this graph will look something like this, but this will always lie between uh, x and minus x. Right? So that's why we use the sandwich theorem. This graph can run somewhere like this, but this is bounded above and below by this line y equal to x or y equal to minus x. On both these lines actually they converge to 0, so that's why this limit is actually equal to 0. By using sandwich theorem we have proved this earlier, so that's why I am not getting into the detailed proof here. So basically what does that mean? This graph has a tangent because the slope of the curve is actually the slope of the curve is actually 0 at this point. Right. Because f of 0 is already given. F of 0 is actually 0, it is already given. Right. Now let us do another interesting thing which slightly related. Let's say the graph of the function is x sine 1 by x. Earlier it was x square sine 1 by x. This was x square sine 1 by x, and now it is x sine 1 by x. Right. Now whether it has a slope or not. Similarly, we will do the same thing. G of x naught plus h minus g of x naught. X naught is anyway 0. G of h minus g of 0. G of 0 is anyway 0. G of h is what? H sine 1 by x by h. So here limit x h tends to 0 sine 1 by h. Now this graph fluctuates a lot. Earlier we discussed this also. It fluctuates a lot near the origin, and there is no limit at this point. Whether you can't take this point or this point or this point, any point, you cannot take sine 1 by x graph. Earlier we discussed, right? So there is no clear limit for sine 1 by h. So we cannot clearly say what exactly is the slope of this graph at origin. Right, guys? We cannot clearly say. So that's why here we cannot define the tangent. Right. To define the tangent, we should know what is the slope of the graph at that particular point. Right. Then we can define the tangent. But now we don't know. Right. We don't know the slope of the graph at that particular point. So we cannot define the tangent. Alright, guys. Hope you understood this. The basics of calculating slopes of curves, as well as the basic understanding of what is the differential. Right. The important points to note is this is called the difference quotient, which is also called which is also the slope of the graph at this point x naught, f of x naught and f of x naught. And at this point at x naught, if you want to draw the tangent, the slope of the tangent is also this thing, right? And this also means change of the graph, change of the curve y with respect to x. Right, change of the curve f of x with respect to x at this particular point x naught, which is also called derivative at this particular point. Right, guys? Hope you understood this. Thank you.